Now, our topic for today is reflections of light on plane surface. The topic is still underway. That's why you need to go and watch the previous video for you to understand this one very well. And let me tell you something. When we are talking about reflections of light, we see an object as a result of light that they reflect to our eyes. Otherwise, we will not see it. If you want to get the truth, go and put object in darkness where there is no light, so that we will not see that object. So we see object as a result of light that they reflect. Now, in the previous video too, we talked about different material. We said some produce light by themselves, while some reflect light. They cannot produce light by themselves, and we call them non-luminous object or body. Today's topic will be based on that of non-luminous object that can reflect light, especially the glass. Now, I said glass. Don't forget, in our previous video too, we said glass will allow ray of light to pass through, not to reflect. Now, how can we now make a glass surface to become reflecting surface? That's why you need to coat the other side. So if you have your glass like this, so if this side is coated, then this one will be what? Normal to the surface of the glass. If you allow ray of light to fall on this glass at certain angle, take note of that. If you allow ray of light to fall perpendicular, it will reflect back on the same direction. It will not look as if there's no reflection, but just allow it to fall at certain angle to the surface. So this ray that fell on this, we call it what? Incident ray. Then the one that will now leave the surface, instead of passing through, because the other side has been coated, so the ray of light will not pass through again. It will now what? Reflect it back. We have done that when we are dealing with properties of wave. Now, it will reflect it back like this. Now, another thing is, will it just reflect the ray of light? It will follow certain law. That's why we need to first of all understand the law of reflection. The laws of reflection, there are two. The first one says the incident ray, reflected ray, then and this normal, all light on the same plane. It's not that the incident ray will be here, reflected ray will now be here. In that case, it will not follow the principle or the law. So the incident ray, reflected ray, and this normal all lie on the same point or on the same plane, and that is one of the two laws. Then the second law says the angle of incident, the angle between this incident ray and this normal is called angle of incident I. Then the angle between this reflected ray and this normal is called angle of reflection R. That's why the law, the second one says this angle must be equal to this angle. Take note of it, that statement. We will still use it. That is, the angle here must be equal to this. So that is what the two laws of reflection. Don't forget again, this side must be coated before glass will reflect light. Now, we have two major types of reflection. So sometimes the surface will reflect rays of light parallel to each other, regular, so that if you have your coated glass like this, allow ray of light to fall on it like this one. So this one will follow what? Law of reflection like this. Then another one parallel to it. This one, that is if the surface is smooth. So for a smooth surface, we have regular reflection. But if the surface is rough like paper, so despite the fact that you have the parallel ray or incident ray, the reflected ray will not be parallel to each other because their angle of incidence are different. Though automatically they are going to have different angle of reflection. For instance, you have this surface, here, and you put your touch on it with ray of light, so automatically some rays will fall on this top, while some will fall at what? Inside. In that case, the angle of incident will not be equal, despite the fact that the rays are parallel. For instance, I have this here, it can be like this, then another one parallel to it. So you now discover that despite the fact that the rays are parallel when they are coming as incident ray, but their reflection are not parallel to each other again. So this kind of reflection is called irregular reflection or scatter reflection. Let's go to how image formed by plane mirror. If you have your plane mirror, we all know that we normally stand in front of plane mirror and we see ourselves there. When you see yourself there, that kind of image you are seeing, can you touch it? You cannot touch it, but you can see it. The image is at the back. It's not real. It's factual. So you cannot. That's why we need to know the difference between real image and factual image. For real image, you can touch it like this and you can see it, and it will appear on the screen. For factual image, you can only see it. You cannot touch it. If you place a screen at the back of the mirror, you will not see anything there or in front of you. It cannot be caught on the what? On the screen. Now, for instance, let's say you have your plane mirror like this. Then you have your candle. Let's say you have your candle here. Then a ray of light from the top of the candle will come like this. Then the ray will reflect back. Follow the law of reflection. Then another ray will come like this. Then this one too will follow the law of reflection. So whoever wants to look at the image of the object, we place his or her eyes here. Then how will he now see the image? See, you trace this one like this, and let's trace this one too. So you can see that I use dotted line to indicate that the image is factual image. The image is not real. So we now have it. Don't forget, the two rays, they are from the top of the object. So they are going to form the top of object. There, as you can see it here. So the image has the same distance as object in front, the same size here. So in that case, it has unit magnification. Don't forget, when we are dealing with magnification, we say magnification is equal to the image height over object height, or image distance over object distance, or image size over object size. So in that case, the magnification of image formed by plane mirror will be what? 1. Because if object is 20 centimeters tall, image also will be what? 20 centimeters tall. So image height 20, object height 20. So this we cancel this to give what? 1. Therefore, formed by plane mirror has unit magnification. Listen to what you need to know about how ray of light reflect on a plane mirror. So if you have your plane mirror like this, while this side is potent, don't forget the first thing you must draw your normal. So I have my normal. So if this is incident ray, this is incident ray, so this one will be what? Reflected ray. Angle of incident I, angle of reflection R. Then we have this part, the remaining angle here, called angle of glass G. Therefore, angle of glass G is equal to 90 minus angle of incident, or angle of glass G, because this one too is angle of glass. This and this, they are equal. Since this and this are equal, Therefore, angle of that can either be 90 minus angle of incidence or 90 minus angle of reflection. Then there's another one called angle of deviation. Don't forget this ray. Normally this blade is going like this. Like this. Then instead of going straight like this, the ray now deviated to this side. Therefore, angle of deviation is everything like this. The whole of this. Then in that case, if you look at everything, it's a straight line like this. From here to here, angle of deviation D plus R and plus I. Therefore, 1I plus R plus D is equal to 180. And don't forget, I and R, they are equal. You can use I to replace both. That will give you 2I plus D is equal to 180 degree. Then what is D? We are looking for D, angle of deviation. D is equal to 180 minus 2I, or you say D is equal to 180 minus 2I. Still the same thing. Now the next one is number of image formed when two mirrors are inclined. When you have two mirrors, you incline them together. You can incline them at angle 90 degrees to each other, or they are parallel to each other. For instance, if you have these two mirrors, we have one here, another one here. If they are like this, it means they are parallel to each other. And if they are parallel to each other, the angle between them is 0. Then, if you incline them such that they are at what? Angle 90 to each other, like this. So the number of images to get, it will be 3. Because the angle between them is what? 90 degrees. We are going to calculate everything. Then, if you make them to be at what? Angle 180 to each other. So you get just only one image. Now, let's go to the formula and see. So the formula for calculating the number of image formed when two mirrors are inclined is number of image is equal to 360 over theta minus 1. Please don't make mistake in this formula. Some students normally use it like this. They will now raise this one up to now give them 360 minus 1 over theta. It is wrong. So it's supposed to be 360 over theta minus 1, where this theta means angle of inclination. Then for instance, if you have two mirrors inclined at angle 90 degrees to each other, what will be the number of image formed? So we have to be what? This number of image is equal to 360 divided by angle of inclination in that case is what? 90. Divided by 90 minus 1. Then 360 divided by 90 will give you what? 4. So now be 4 minus 1. So the number of image is what? 3. I'm going to have 3 images. But what of if you incline them parallel to each other? When they are parallel, it means the angle between them is what? 0. So this one will become number of image is equal to 360 divided by what? 0 minus 1. And any number divided by 0 will give you what? Infinity. That is, we are going to have uncountable number of images. So this one will give us infinity. Then infinity minus 1 still remain what? Infinity. That is uncountable. That's why most of the time when you go to Zaloon, you see that when you have one mirror like this side and another one at this side, you are now sitting between the two mirrors. You know, when you look like this, you see the first image, then you still see another one, you see another one, you continue seeing the image until where you can what? See. It means you cannot see the last image. You can incline your mirror at an what? 60 degrees. What will now be the number of image? Just put 60 here. 60 here. So this cancel this. Then this, that is 6. So number of images will be what? 6 minus 1, which is equal to 5. So just make sure you have this formula and you write it what? Properly. Now, the next one is set of rotating mirror, our plane mirror. Then we have normal, like this. If the angle of incidence, then we have reflection. So this is angle of incidence I, and this is angle of reflection R. So if you look at it, this is incident ray, reflected ray. Then the total angle between the incident ray and reflected ray will give you either 2I or 2R. Don't forget that we said angle of incident is equal to angle of reflection. So the total angle between this and this. Now let's just rotate this one with an angle theta. So this is a new mirror now. Then this is angle of rotation. This one too, angle of rotation. So in that case, this normal, our former normal, let's call it N1, cannot serve as normal for this mirror again. Then now we are now going to have another normal again. So this is new normal, N2. And don't forget, this incident still remains at the same point. Therefore, the total angle of incidence is from here. This place is still remain I as it was before. Then this is what? Angle of rotation, this theta is here. So if angle of incidence is I plus theta, so the new reflected ray will be here. So from here to here is our new reflected ray, which is also equal to this theta plus what? R. And R is same thing as what? I. Therefore, the total angle between the incident ray and the new reflected ray will be I plus theta plus I plus theta. So which is equal to 2I plus 2 theta. Then subtract our former 2I minus 2I. So it means this one will give us what? 2 theta. Therefore, if you rotate a mirror by angle theta, the reflected ray will be rotated by what? 2 theta. It's common white question. White question just say if a mirror is rotated by 30 degrees, at what angle will reflected ray be rotated? You just multiply it by 2, which is 2 times 30. That is 60 degrees. Very simple. Now, applications of plane mirror. Plane mirror is very close to us. We use it almost every day. When you are going out, we use plane mirror as what? Looking glass. We use it as looking. Apart from that, we use it for what? Kaleidoscope. Then we use it for what? Periscope. Then we use it for shaving mirror, dentist mirror, to check the teeth. So those are the applications of a plane mirror. Then our next topic will be on a reflection on curved mirror. This one is plain like this, plain mirror, not curved. Then the next one will be curved mirror.